I just want to remind you guys too, the session is recorded, just so you know. I mean, you can see it on the slide too, but just to tell you again, just to make sure. Because it's kind of a weird time for people, time zones ahead of London, because it might be pretty late for them. So that's also a reason why we're recording this session too. So, yeah. Let's go one more minute and we'll start. I think people will come in while we do the session too, but it should be fine. I just wanted to mention too, I said it in the email, but this session doesn't depend on what you did in session one. So if you didn't finish session one, that's fine. We'll be using a different model anyway. So because I didn't want everyone using different models, they're different robot they made in last session. So yeah, so we'll be using one that everyone has that I put in the zip file in that email we sent yesterday morning. So yeah. Okay, I guess I'll just get started and then more people will come while we do the session.
Okay.
So
Just quick question. How long will it last? How much time?
Half an hour maybe. It's not gonna take as long as session one for sure if you were there.
Oh, so it's not 3 hours long.
Oh no, it's not 3 hours. No, for sure it's not 3 hours. It
How
was
long
30
was
minutes.
one because I missed it?
Sorry?
How long was session one?
I think it was around an hour, I think. We have a recording. It's in our
okay.
Slack, so you can check that out.
Okay.
Yep.
Thank you.
No problem. Okay, so in that case, I guess we'll just get started. So welcome to session 2 of 3D Printing 101. I hope you guys had fun in the first session. First session was a lot about CAD, how I use CAD, how I want to make things from scratch. This time we're actually going to be using our 3D printing software now, because the thing you export from Fusion 360 isn't the final file you'll be putting on your 3D printer. You have to process that file into something where the printer can actually understand what that object is. So this is what this session is for. So just a quick run through what we're going to be doing. It's a short session. It's not as long as the last one. So we'll be learning the basics of Prusa Slicer and creating basic 3D printable files, and these are called G-code files. It's a more advanced topic, but I'll be teaching you how to use threaded inserts and why to use them. It's more, I mean, your printer will be fine without them, but it's just a nice thing to have. And also frequent user errors and how to avoid them. So when we had our lab open, these are things people would frequently do, which would mess up their print, or like they're like, oh, why is it not working? If you knew these things beforehand, your print should be fine. So what we'll be using today is Prusa Slicer. So if you have it downloaded and installed already, you can start up now. We'll be using it throughout the session. If you haven't downloaded it already, you can go to this link here, or you can Google Prusa Slicer. I hope you guys had it downloaded it beforehand, because it takes a bit of time to install it. So I'm gonna be alt-tabbing between Prusa Slicers. So I hope you guys can see this too. So this is my Prusa Slicer basically, and I'll be going back and forth between the two, the presentation and the Prusa Slicer. Okay, so the zip file that you guys got in the email, if you extracted the contents of that, there should be a file called 3D Benchy. So I want you guys to import that file into the Prusa Slicer. So I'll show you how you do that now. So if you go over to Prusa Slicer, you go up to File in the top left, and you go on Import, and then Import STL, OBJ, AMF, whatever, but it should be an STL file. So if you click on that, and then find your files, I've just put it on my desktop. Just find it wherever it is for you guys. So just double click it, or you can click on it and then click open. I'll give you just some time to actually find the file. So I'll give you a few seconds and then we'll continue. Okay. So hopefully you've imported your file now. So it's a boat we'll be working with. This is a pretty generic 3D print. A lot of people print this first as kind of like a stress test for their 3D printer and stuff like that. So just to check everything's okay. So just for navigation for Prusa Slicer. So again, in Prusa Slicer, if you hold left click, you can rotate around your object. So it's pretty simple. There's nothing fancy going on here. So that's left click. If you hold right click, you'll pan in like 2 dimensions. That's also useful. And you can zoom in and out with your scroll wheel and stuff like that. So it's pretty simple controls, to be honest. Should be pretty straightforward. So let's go back to presentation. So position and scaling. So one of the first things you might want to do is actually move your thing you just imported. So you can go over to the top left button here and you can move it. So you can pick the axis you want to move it if you want to, or you can just hold left click on the boat and you can move it wherever you want. You can do that. I don't want to move it though, so I'm just going to undo what I did. So you can go to edit and undo, or you can do Control Z2 as a shortcut. Oh, I just deleted the whole file. My bad, guys. So the next button is you have to have your boat selected, by the way. So next one is scaling. So you can scale your boat too. You can have a really wide boat if you want to. You can have a long boat. It's up to you. I prefer the size of my boat, so I'm just going to keep it like this. Also with rotation, you can rotate your boat if you are your object. It's up to you. This is mostly used for things you've built and it might not import correctly, so you might need to move it around, rotate a bit, whatever. And the last one is actually picking, you can pick a side which will have contact with the build plate. So let's say this was wrong for some reason. I want this side of the boat to be on the build plate. So you can click on this and now, yeah, the boat is rotated. So like the bottom, it's is rotated. So it's starting from there now. But what we had before was pretty okay. So I'm just going to undo that as well. It's just to show you how you use these different options in Prusa Slicer. So those are the basic options or controls actually. So for 3D printing, there's 4 main filaments, especially in our lab. These are usually the ones we have. So it's ABS, flexible, PLA, and PETG. These are all, well, except flexible, these are all abbreviations for the plastic name. But yeah, these are filaments we use for 3D printing. And this is a small table as well for their pros for each filament. But actually, PLA is actually by far the most popular among beginners and intermediate users just because it's so easy to print. It's also low cost and also is biodegradable. It's good for the environment. So that's why PLA is very used in 3D printing. If you want more info, like there's, if you go to the link here, there's loads more filaments you can pick between, and there's like a 30-row table giving you all these pros and cons for each material and stuff like that. But usually PLA is the way to go in 85-90% of the cases, so it should be fine. So choosing your material. So you should be knowing this beforehand. So I'll just show you. So it's in the top right. If you can go on filament and you can pick whatever you want. So I'll go over to Prusa Slicer now. If you go to the top right. So usually you won't be using Prusament PLA unless you know that is the PLA you're using. There's a special kind of PLA. But if you don't know what type of PLA you're using, you might as well just go generic PLA. It says it in the name. It's just for any generic PLA filament you're using. This is usually the setting you want to be going for. So and if you don't see the thing you want to be or the filament you want to be using, you can go to add and remove filaments here at the bottom. And this gives you a full list of all the plastics, you can tick them off, and then they'll come up in that small menu afterwards. But usually this is sufficient. So yeah, generic PLA should be fine. So for print quality, so there's this what can I say? You have to choose between time and the quality of your print, or how detailed your print you want it to be. So if you go to your print settings, usually I do 0.20 millimeters speed settings. So that's just for any sort of 3D print I want to make. If you're making more of a figurine, for example, or statue, I want a statue, but as a figurine, for example, or you want something very high quality, you can go for 0.15 quality, for example. These are more, I can't really give you an like objective which one will look better for that specific print. It's more just trial and error, and you can see how each one looks. But usually I just go for 0.20 speed, just to be on the safe side. It doesn't take that long, and the quality is decent, so that's what I usually keep it at. So for infill, so what is infill? Infill is, so when you're 3D printing something, we don't usually print fully what's inside of the object you're trying to print. This is mostly just because we don't want to be wasting plastic. You won't be seeing the inside of the plastic or the object you're printing. So that's why we usually just print a percentage of the inside. But then if I say, oh, I want to fill in 10% or 15% of the insides, how do you want me to print that 10, 15%? And that's when infill pattern comes in. So you can see a picture at the bottom how they've done, I think it's 10 or 15%, how they've done it using these different patterns. So there's linear, hexagonal, Moroccan star, cat fill. There's all these different kinds of patterns that you can do. And there's pros and cons for each. Some use a bit more filament, but they're stronger. Some use less time, but are a bit weaker. So usually linear, more the simpler ones are usually sufficient. Also, as you increase your infill or the percentage, you're printing more plastic, so you're going to be spending more time printing. So just keep that in mind too. So we usually use infill around 15, 20% or something like that. So actually doing this in Prusa Slicer. So for just the percentage, if you just want to change the percentage, you can look at the right side of Prusa Slicer. You can see infill and there's percentage, so you can change that there. If you want to go for more advanced settings, you can go to the print settings in the top left. So I'll just show you now. So, okay, let's say it's 20% right now. Let's say I just want 15%. So let's go over to 15%. And if you actually want to see how it is, you can click on Slice Now in the bottom right. So if you click Slice Now, this might take a bit of time depending on your computer. So I'll just give you a bit of time, a few seconds, and then I'll go ahead. So if you use this slider on the right, you can hold left click on the top and you can get a cross section of your print. So if I just go down a bit, you can see the middle of the boat. You can see we've gotten a grid type pattern, and this is around 15%. So let's say I actually don't want this grid pattern. I want something else. So let's go over to print settings in the top left. And then you go on infill, and you can pick your, so again, you can pick your infill density. We'll just keep it at 15% for now. And for your fill pattern, so so we had grid, we can go for whatever we want here. A more fancy one is gyroid, and it's not that, it's actually pretty useful, actually. It's pretty strong. Only thing that's it's not bad about it, but it uses a lot of the motors in the 3D printer. It's not straight, so it's using a lot of the stepper motors in the 3D printer. But anyways, I'll show you guys this one. So if we go back to our platter now, just another tab, just go on the top left platter, and we have to slice it again. So because we've had new printing settings now. So if you go on slice again or slice now, again, this might take some time. This might take a bit more time because it's not linear, but you can see now we've gotten some sort of wavy pattern, and you can look through your 3D print cross section. It's pretty cool, actually. So yeah, again, this is gyroid. to get out of this feature, so you can just put this back to the top, this bar, and bottom left, you can see this cube, just to get back to our normal 3D editor view. So we're back to our little boat again without being sliced. Yeah, okay. So if that's okay, I'll continue. So that's infill, basically, an infill pattern. So now supports. So what are supports? These are extra material you put where there are overhangs or steep angles. Because for 3D printers, they print on top of printing of plastic layers. So when you're printing and there's no plastic under to support, it'll just sag or it'll just drop the plastic. So that's why we usually use supports. A good example is this picture actually of this dog. So you can see the belly side is where they've actually put the support. If this support wasn't there, the belly is not being supported by anything, so that plastic would just sag and drip off. So that's why we use supports. Let me just see what else I've written here. So we usually try to avoid supports while we can. Sometimes you can orient your print in a way where you don't have to do supports. That's why at least what I try to do. A majority of people actually do that because it's kind of a waste of filament needing to do supports and then you have to rip it out with some sort of pliers or your fingers or something like that. So try to avoid it. Whereas if it's unavoidable, like in this case or in the orientation they've done it, you have to use supports here. So usually there's usually maybe around 45 to 60 degree overhang, you might need to use supports. Is again a very trial and error kind of thing. You can't really tell from just looking at it. There's obvious ones or there's not obvious ones. When it's in the middle, it's kind of hard to tell which ones. Oh, sorry guys. It's kind of tell how it's hard to tell when it needs supports and doesn't need supports. Yeah, so there's different methods of generating supports. I'll show you guys in Prusa Slicer. Also in Prusa Slicer, there's support blockers and support enforcers. I'll show you guys in Prusa Slicer too. So we'll just get right in. So the basic support method is just going to supports, picking one of these options here. So usually support on build plate only is usually the way to go. It doesn't give you too many supports. And it gives you a decent amount of supports if it's required. So we can go over to Prusa Slicer and I can check that out. I'm going to go over to supports and I'm going to go on support on build plate only. So it just builds supports starting from the build plate and up. So we'll click on that. If you get this option, you can just click on yes, that's fine. So we've enabled supports now. You can slice now and it might take some time again. Oh, it's taking a bit more time for me at least. I can now see these green columns here, which are supports basically. So in this case, our object actually doesn't need any supports. I'm just showing you guys anyway. This is just how you make supports. So yeah, some people might still be making these supports. It's okay. It might take some time, but yeah, this is how you make these supports. So let's say, for example, I don't want supports at the back. So we can go over, so let's go back to our 3D editor view on the bottom left. Right click on our boat and we can do a support blocker. So if we click on that, okay, so we have this little box where anything inside this box will prevent these supports from being made. So I'm just going to move my box to the back of my boat. So here's the navigation I told you in the beginning of the presentation to move it to where you guys want it. Maybe scale it a bit to something like that. Maybe I think that's fine. So if when you're happy, you can click on slice now again. So now you can see we have the supports, but we've gotten rid of the ones at the back of the boat. So so this is more for advanced users. Usually, if you want supports, you just get away with support on build plate only, and that's pretty much the end of the story. But it's just in case if you guys have any special thing to print and you're saying like, oh, maybe you don't need supports here. So
excuse me?
Yeah.
You can ask a question.
Yeah, sure.
How come we're not putting supports in the main arch of the boat, which looks more fragile?
Oh, yeah, so you can do that as well. I was actually we're gonna do support enforcers now. So again, the boat actually doesn't need anything, any supports at all. It's actually just on the limit of what you can get away with. That's just, as I said, it's more trial and error kind of thing with the 3D printing and everything. It's you can't really tell. You just have to go ahead and see how it is. But yeah.
And my other quick question is, does this program only work with Prusa keyboard 3D printers?
Actually, no. So I didn't actually show you guys this, mainly because this is mainly the only type of printer we have. I think if you go over to, let's see here, let's see here. You can go over to your configuration wizard and you can, when you get to, yeah, so you can start using these different printers. You can go in custom printer as well, and you can pick your own printer if you want. I'm not going to go into it because there's mainly 3D printing at our lab, so we mainly use this printer, so I didn't really show you guys. But yeah, for sure you can use this for other printers too if you want to. So anyway, so moving on. So just quickly support enforcers too. So I'm just going to delete this by right-clicking on the box and just deleting it. There we go. I've deleted the box or the support enforcer. So support blocker, sorry. So to add a support enforcer now, so we'll right click on the boat again, support enforcer, move it. So we'll move it to the arc of the boat and then we can try that out. So we just move it over, scale it up a bit. Something like that is fine. And we just click slice again. Yeah, again, it takes some time. So it actually hasn't done that good of a job, but you can see it's added some extra supports on the boat, which is trying to support this arc, basically. And yeah, that's basically it for supports, or at least these boxes you can use. So I'm just going to delete these again. So you can right click on the box, just delete it, and then it's gone. A few other options. So you can do supports only in these support enforcers if you really want to. I've never used this option before, but it's up to you if you want to use it. There's also everywhere, or anywhere it can put supports, it will put supports. So it's usually adds a bit too much supports in my opinion. So you can use this plus support blockers if you want to. Yeah, you can see like it's gonna be a hassle getting this out. This once your print is done, plying it out for something, it's gonna be hard. So I usually just go with support on build plate only. But in this case, we don't even need support. So to be honest, you can leave it on support on build plate if you want, but I'm just going to keep it on none because we don't need supports at all. So I'll just leave it at that. Okay, so I hope everyone's following along. I have written instructions too on top of this recording, so if you want to go back, it should be fine. So there is this other option called Brims. So you do it by simply clicking this check mark here, and that's pretty much it. You click on Brims. So this helps with if you don't have that much surface area with your print bed and you need a bit more space to keep the print down on the build plate, you can enable Brim, and it makes this small little plastic thing around it, so it's just more surface area for the print so it doesn't fall off mid-print or fail or anything like that. A bit more advanced option, if you go to print settings, it's skirt and brim, and then you can go on your brim width and actually change this too. So you can go on like, well, 15 is very excessive. I would go like 10 millimeters max, but just to show you, you can slice again and you can see now I've made this 3 times as wide. So that's pretty much brim. Usually it's a good idea to have a 5 millimeter brim on your print, just to make sure it stays there for good. Yeah. So again, we can go back to the 3D editor view. You can keep on going back and forth if you want to. Okay. So finally, so if you want to export your print or the thing you want to print, you're happy with it, you have done your infill, brim. I'm actually gonna put it back to 5 millimeters. I think that's a bit more reasonable. Gonna slice. And I want to export the G code. So this is the file you actually put on. You usually have the SD card into your computer ready to put this file on. So I'm just going to export G code. You can put it anywhere you want to put it. So it would be on the SD card if you had the printer next to you, take the SD card out, put it into your computer, and you put this on the SD card. In this case, I don't have the SD card or anything like that, so I'm just going to put it on my desktop, save it. And that should be it. So it should be like, in reality, it should be on the SD card now, put into the printer, and you can actually select it pretty easily. I can't show you guys now, but it's mainly a Prusa slicer workshop. So I just want to quickly go through some printing tips while you're printing, if you ever get to print at our lab. So usually you want to stay at the first few minutes of your print. So a lot of people's prints fail in the first maybe 5 minutes. A lot of people print or want to print something that are 10 to 12 hours. And we really appreciate it when you can at least spend at least 5 minutes just to make sure everything's stable, everything's settled, the plastic is sticking to the bed properly. So make sure to just stay there at least for a few minutes. If you realize your print isn't sticking, please use our isopropyl alcohol or IPA and just spray some on the build plate to clean off any germs or grease or anything. Grease on these build plates are really destroy the adhesion of these plates, so you need to clean these constantly. So yeah, make sure, consider doing this if your print doesn't stick. Also, it's very high temperatures while you're printing, so actually the print head while you're printing PLA is actually around 210 degrees. And the build plate is around 60 to 70 degrees Celsius. So please don't try to touch it or anything while it's printing. Committee members themselves have hurt themselves from touching it, so please just don't touch it. Stay away from it, let it do its printing. And also keep your prints small, so it's better to have 3 small prints that might take 2 to 3 hours each than have a huge print that's 13 hours. Just because you can split these prints and it's less prone to failure, basically, because failures can happen anytime. These machines aren't perfect. So also most common user errors for also just basically more errors people do is basically that they have the wrong printer settings in the slicer software. So if I just go back to Prusa Slicer really quickly, so you can see I'm using the Mark III S right here. So this is the one we mainly have in our lab. Again, if you have a different printer, feel free to add it here and whatnot. It's up to you guys. But yeah, usually some people have chosen the wrong one. So you've chosen the original Prusa Mini, but you're printing on a Mark III S. So make sure you've chosen the correct printer. That's one usually something yeah, people do wrong. Okay. And finally, so this is actually the creator of the Prusa. He's the founder, and he's just simply showing how to remove a print from the build plate. So these printers have a steel sheet bed. So what you do is it's magnetic actually. So you take it off, make sure it cools down first. This thing is 60 degrees while you're printing, so they cool down, and you just take it off and you just bend it in 2 ways basically, and it should detach. And that's pretty much, that's as easy as that's pretty much. It doesn't get easier than that. So that's how you detach your print. Lastly is just threaded inserts. So okay, so by far you don't need to use this in your prints, especially if you're a beginner. But it's just nice, especially if you're gonna be using screws with your 3D print, for example. These are basically inserts you heat them up using a soldering iron. So you can see in the second picture, it's the tip of a soldering iron, and you heat up the thread insert and you stick it inside your 3D print. So it melts the plastic around it and it gets into the print. So you use this so you can use screws with your 3D print, and it's actually makes it stronger. since your screw isn't digging into the 3D print plastic, it's actually it's not digging in, but it's screwing into the threaded insert, which is actually much better. Yeah, so yeah, why use them? It fastens other parts better and it becomes stronger overall. This is more of a advanced topic. If you want to really use it, you can ask one of us committee members. We've used these quite a bit. So yeah, again, a bit advanced, but still, it's nice to know that these things exist. Yeah, so that's pretty much it. The session wasn't supposed to be that long anyway. These are basics anyway. Join our Slack channel if you haven't already. We have a 3D printing channel too. If you want to talk about 3D printing, we have loads of passionate people there. And yeah, join our 101 participants too if you have any questions for this session, anything like that. And yeah, are there any questions, guys? Is there anything that wasn't clear or any questions about the contest maybe? I don't know. It's anything.
I have one question.
Yeah.
So basically, I just joined the society yesterday, so I missed the first session for the 3D printing. Do you know where I can find the recording for that?
So that's actually on our Slack. So if you go to our Slack, it should be there. It's like a YouTube video or something, so it should be there. Yeah.
You mean like the 3D printing channel, like
Yeah.
Hmm.
Yeah. So no, it's actually in our 101. Yeah, I'll drop the PowerPoint too. As well. I mean, you'll see it in the video, but I'll drop the PowerPoint too. But yeah, everything is put on our Slack usually. So 101 participants, there's this text channel there. You can that's the past session there. This session will also be recorded. It's recorded right now, and we'll upload it there too. So yeah, just check on our Slack.
Okay, sure, thank you.
Any more questions, guys? I'm on Slack as well. If you guys want to message me anytime. So I should have introduced myself earlier, but I'm Armand. I'm the guy that you see the newsletter from every Sunday, Monday, something like that. So yeah, so you guys have been getting emails from me. But yeah, talk to us on Slack for sure if you guys have any questions about 3D printing. Yeah, so if there's no other questions, then I guess this is it for the session. I hope you guys found it informative, fun, or hope that you guys actually try and print something. So okay, guys, I guess that's it. Thank you so much. Yes, yeah, so I'm not sure how we do it now. I guess you guys could just leave. I don't know how we do this, but yeah, it's okay, guys. You guys can. I know. Yeah. Let's see here. How do I? No problem, guys. It's been a pleasure doing this session.